March 6, 1944, 28,000 feet above Berlin. The dawn light barely touched the horizon when the sky exploded into chaos. Trails of vapor twisted like white scars through the pale blue above the Reich's capital. Far below, the city still burned from last night's bombing. But up here, the air belonged to men and machines locked in a battle that would define the future of air warfare. The 56th Fighter Group, the legendary Wolf Pack of the U.S. 8th Air Force, had been escorting bomber formations when the Luftwaffe struck. Dozens of Focke-Wulf 190s and Messerschmitt 109s rose from the haze, slicing into the bomber stream with ruthless precision. The Germans dove through, fired, and began their familiar escape, pulling into steep, defiant climbs toward the sun. It was a move they had practiced for years, the maneuver that made survival possible. Until that morning, the Americans could never follow. The P-47 Thunderbolt was a beast of a machine, nearly 7 tons of metal, armed with 8.50 caliber Browning guns and powered by the mighty Pratt & Whitney R-28 engine. It could dive like a comet and soak up punishment that would destroy any other fighter. But it had a fatal flaw. In a climb, the heavy Thunderbolt bled speed and lift like a wounded bird. German pilots knew this. They exploited it again and again. Dive, strike, climb, vanish. But on March 6, 1944, that pattern shattered. When the German formation pulled up into their steep vertical escape, the Thunderbolts did not fall behind. They rose with them, higher, closer, locked on. At altitudes where air thinned and engines screamed for breath, the P-47 stayed on the chase. And then, at the edge of stall, the Americans opened fire. Flashes burst across the morning sky. One Messerschmitt spiraled down, trailing smoke. Another burst into flame as the pilot bailed out. Across the battlefield, the impossible had happened. Thunderbolts had caught the Luftwaffe in their own maneuver. By mission's end, the 56th Fighter Group claimed 11 German aircraft destroyed. Not one Thunderbolt was lost. The Luftwaffe's confidence, built on years of dominance in the climb, began to crumble. What the Germans didn't know was that the change had begun far away, months earlier, in the quiet offices and roaring workshops of American industry. The transformation of the Thunderbolt from lumbering brute to high-altitude predator started not with a new engine nor a new airframe, but with something far simpler, a propeller. Winter 1943. Across the Atlantic, the war in the air hung in the balance. American bombers bled over Germany. Every mission grew costlier, every pilot more aware of how vulnerable they were. Reports poured into Republic Aviation, the builders of the P-47, and the story was always the same. The Germans dove through the bombers and escaped by climbing into the heavens. Pursuing Thunderbolts strained and stalled, their engines screaming, their targets fading into the blue. At Republic's headquarters in Farmingdale, Long Island, Chief Engineer Alexander Kartveli studied the data with growing unease. The Thunderbolt's engine was magnificent, 2,000 horsepower of relentless strength. Yet its narrow-bladed Curtiss electric propeller could not harness that power efficiently. Designed for high-speed cruising above 350 miles per hour, the blades sliced through the air like knives. But at the low speeds of combat climbs, they simply couldn't bite into enough air to pull the fighter up. The engine roared. The aircraft barely rose. In engineering terms, the Thunderbolt was suffocating on its own power. Kartveli understood the physics. Propeller thrust depend on surface area. The broader the blade, the more air it could move. But the trade-offs were brutal. Too wide, and the engine would shake itself apart from vibration. Too heavy, and torque would rip the plane sideways during takeoff. Finding the perfect balance between strength, lift, and stability would require an entirely new blade design, one that could be mass-produced for thousands of fighters already in service overseas. The challenge was clear. The war was killing pilots faster than the engineers could draft solutions. Two companies were chosen to fight this hidden battle: Curtiss-Wright, builder of the original propeller, and Hamilton Standard, the innovative Connecticut manufacturer behind countless Allied aircraft. The U.S. Army's directive was simple: fix the climb and do it fast. Through the brutal winter of 1943, the factories worked without pause. Engineers lived beside their blueprints, testing new shapes in roaring wind tunnels, measuring torque vibrations, blade stress, pitch response, and resonance frequencies. It was cold industrial war, fought not with bullets, but with formulas and prototypes. Hamilton Standard's team broke with tradition. Instead of slender aerodynamic blades, they created something bold, almost crude in appearance. The new design was paddle-shaped, wide, rectangular for most of its length, then tapering only near the tip. These blades didn't slice through the air. They pushed it, heaving against the wind like oars in a storm. Curtiss-Wright countered with their own concept: a more elliptical shape, smoother airflow, and distinctive blade cuffs that reduced vibration near the hub. Both designs looked ungainly beside the elegant narrow blades of earlier models. Yet wind tunnel results defied skepticism. At lower speeds, the new blades produced dramatically more thrust with minimal loss at high speed. For the first time, the Thunderbolt's engine could truly breathe. By April 1943, Republic Aviation received prototypes from both manufacturers. Flight testing began immediately, in Long Island and at Wright Field in Ohio. Pilots reported the same sensation: the aircraft wanted to climb. The Thunderbolt, long mocked by some as the Jug, was beginning to find its wings. At that moment, nobody could know it, but this engineering experiment would change the course of the air war over Europe. Within months, it would save thousands of bomber crews, reshape Allied tactics, and end the Luftwaffe's dominance of the climb. A revolution in the sky, born not from a new airplane, but from 4 blades of aluminum. Winter gave way to a bitter, restless spring. 1943 would become the year when blueprints turned into weapons. Inside the vast metal halls of Republic Aviation, the smell of cooking oil and aluminum dust filled the air. Cranes hissed overhead, welding sparks leapt like fireflies, and the sound of rivet guns echoed against corrugated walls. The war was being built not only by soldiers, but by the hands of machinists, draftsmen, and women who worked through the night beneath the blinding glow of industrial lamps. In an office that looked out over the assembly floor, Alexander Kartvelli signed off on a new production directive. Every Thunderbolt leaving Farmingdale would be redesigned to accept a new propeller. The decision meant ripping apart established supply lines and retraining hundreds of mechanics. But there was no time for hesitation. While American pilots fought for their lives in the gray skies over France, engineers fought deadlines and mathematics in equal measure. The race against loss. By February 1943, bomber formations were being torn apart. 8th Air Force losses were mounting at a rate that threatened the entire daylight bombing strategy. German interceptors, sleek, vicious FW-190As and Bf-109Gs, struck in disciplined waves, diving through the heavy 4-engine formations, then climbing back into the thin blue where Thunderbolts could not follow. Every report that reached Washington read like a plea: we need climb. In Ohio's Wright Field, test pilots compared the 2 experimental propeller systems, the hydraulic Hamilton Standard and the electrically controlled Curtiss-Wright. Both transformed the aircraft's behavior. Test engineer Captain Harold Comstock wrote in his flight log, "At full throttle, the Jug no longer grinds against the air. It surges through it like something alive." The mathematics supported the feeling. Rate of climb increased from 2,700 to 3,400 feet per minute. Acceleration from dive recovery improved nearly 20%. The Thunderbolt had found its missing dimension. Yet performance meant nothing without production, and production meant logistics, a second war entirely. The assembly storm. Republic's Farmingdale plant would install Hamilton Standard paddle blades on all Thunderbolts built in New York. The Evansville, Indiana plant would mount Curtiss Electric designs and also manufacture retrofit kits for overseas units already in combat. The Army Air Forces called the plan dual source implementation. Engineers called it madness. In both factories, work crews labored in 12-hour shifts. Each propeller assembly contained nearly 600 individual parts: forged hubs, feathering gears, pitch control motors, hydraulic pistons, electrical contacts, and the massive aluminum blades themselves. Forging those blades was an art. The alloy billets were heated until glowing orange, hammered by automatic presses into rough shape, then milled along precision jigs until their surfaces curved in an exact aerofoil taper. After machining came the polish, a mirror finish to reduce drag, and then the balance test. Each blade was mounted on a vibration table and spun at combat RPM. Any imbalance, even a few grams, could destroy an engine in flight. Every shift produced fewer than a dozen completed sets. But in war, even minutes mattered. Blueprints and blood. At the same time, in the hangars of RAF Wattisham and Boxted in eastern England, the 56th Fighter Group waited. Their Thunderbolts still carried the old narrow blade props. They knew every inch of the sky above France and the Low Countries, and they knew how unforgiving it was. Pilots joked darkly that a German climb was the P-47's funeral bell. Lieutenant Robert Johnson recalled later, "You could dive on them, sure, but when they pointed their noses up, they were gone. It was like chasing ghosts. That ghost would soon vanish for good." Atlantic Convoy. In June 1943, the first shipments of the new propellers left the docks at New York. Each wooden crate, marked Aircraft Propeller, Handle with Care, contained an assembly weighing nearly 650 pounds. Loaded onto Liberty ships, they crossed the U-boat-infested Atlantic in convoys guarded by destroyers and corvettes. Salt air and cold fog wrapped the decks as sailors watched torpedo wakes glimmer like ghosts beneath the waves. 2 weeks later, those same crates were unloaded at Liverpool and transported by rail to air depots across England, Burtonwood, Honington, and Wattisham. Mechanics opened them like treasure chests. Inside lay the wide, gleaming blades that looked nothing like what they had seen before. "They looked like paddles off a Mississippi steamboat," one crew chief wrote home, but the pilots smiled like it was Christmas. Transformation in the hangar. Retrofitting the P-47 was no simple task. Each old propeller had to be removed, control wiring rerouted, balance checked, and the new unit mounted with perfect precision. The job took 16 hours per aircraft. Crews worked in freezing January wind, lanterns hanging from engine cowlings, fingers numb beneath oil-stained gloves. When the first engine roared to life, the difference was visible. The new blades bit into the air with a deeper, slower rhythm, a heavy whump, whump that seemed to shake the ground. Lieutenant Colonel Hubert Zemke, commander of the 56th, watched from the tarmac. The man was methodical, known for calm precision. That morning, as he listened to the rhythmic throb of his newly fitted Thunderbolts, he smiled slightly and said, "Now we'll see if this bird can climb with the devil." The training of the Wolf Pack. January 1944, the 56th Fighter Group began intensive vertical combat drills. Over the frozen countryside of Essex, formations of Thunderbolts spiraled skyward in climbing turns, dived, reversed, and climbed again. They practiced the new tactic Zemke called the rising spiral, a maneuver impossible with the old blades. The pilots learned to convert speed into altitude, to ride the edge of a stall, to feel the moment when the broad propeller faces gripped the thin air and lifted the entire 7-ton machine higher. For weeks they refined the technique until it became instinct.
Their aircraft were still the same model, same guns, same wings, same massive engine. Yet they felt reborn. It was like the plane had finally caught up to the engine, said Captain Francis Gabrusquet. Before, you had to beg it to climb. Now, you just asked. First blood. On January 4, 1944, the entire 56th flew its first mission with paddle blade propellers. Escort duty for B-17s over the French coast. The Luftwaffe appeared as usual, gray shapes in the sun, and dove in. But when the Germans pulled up to escape, the Thunderbolts followed, something no one had seen before. From the gun camera footage recovered that day, analysts watched as German fighters, expecting to outclimb their pursuers, found Thunderbolts still behind them, closing fast. When the film reached Berlin, Luftwaffe intelligence dismissed it as impossible, probably a new American type, they said. But it was no new fighter. It was the same machine transformed by engineering. Industry as a weapon. Behind this triumph lay a logistical miracle. Between June 1943 and January 1944, American industry had conceived, tested, produced, and shipped thousands of complex mechanical systems across an ocean while fighting a global war. Each blade required 14 hours of machine time, each hub another 10. Every crate crossed 1,000 miles of railroad before touching a ship. Factories in Connecticut, Indiana, and New York worked under floodlights around the clock. Women riveters, machinists, inspectors, many never having seen an airplane, became part of a silent army that lifted the P-47 from mediocrity to mastery. This was how America fought, not just with courage, but with coordination. Luftwaffe blind spot. Meanwhile, in Germany, intelligence officers at Rechlin examined wreckage from a downed P-47 captured earlier that year. They noted the unusually broad blades, but misinterpreted them as devices to aid takeoff with heavy loads. No one considered that such a change could rewrite the geometry of air combat. By the time reports filtered upward through the Luftwaffe's bureaucracy, the transformation was already airborne. March 6th, the proof. 2 months later, the Wolfpack would face its greatest test, the Brunswick-Berlin raid. 48 Thunderbolts escorting bombers met over 80 German fighters. The sky became a cathedral of fire. As the Luftwaffe repeated its trusted escape climb, the Thunderbolts matched them move to move. In the thin, freezing air, the wide blades clawed up with brutal efficiency. Within minutes, 11 German aircraft were burning across the horizon. Not a single Thunderbolt fell. For the first time, American fighters had conquered the vertical. A new doctrine. In the following weeks, Zemke's pilots refined what they now called energy fighting. They used altitude as a weapon, converting speed into potential energy and back again with devastating effect. The paddle blade had turned brute force into agility. When news of the victory reached Washington, a line in the report summed up the moment. The Thunderbolt has learned to climb. What had begun as a manufacturing problem became a By February 1944, the sky over Western Europe had become a factory of death. From dawn to dusk, bomber streams rolled east like iron rivers, 400 planes wide, 10,000 men inside aluminum shells, flying through fire. Above and around them, their guardians circled, the P-47 Thunderbolts, newly reborn with the broad, muscular blades that had changed their destiny. In England, the winter air still carried the taste of metal and smoke. The 56th Fighter Group, Zemke's Wolfpack, now flew with the confidence of predators. Mechanics wiped frost from gun panels while the pilots strapped in, engines thundering one after another until the field shook like an earthquake. From the control tower, Lieutenant Colonel Hubert Zemke raised his binoculars and watched his men take off in threes, climbing, spiraling upward into the gray cloud. They were going hunting. The doctrine of the vertical. For nearly 3 years, the Luftwaffe had defined the laws of air combat. Their aircraft, the Focke-Wulf 190A and Messerschmitt 109G, ruled the vertical plane.
The German tactic was simple, brutal, and effective. Attack from above, dive through the enemy, then climb away into safety. American fighters could not follow. The Thunderbolt's weight and drag doomed every attempt. But the paddle blade propeller rewrote those laws. In the briefing rooms of Essex, Zemke's instructors developed new combat doctrine. Gone was the old flat turning fight. The Thunderbolt would now fight vertically, using its massive engine and newfound climb to control altitude and energy. They called it the spiral attack. Lieutenant Francis Gabby Gabreski, commander of the 61st Squadron, became the tactics champion. His voice, calm but commanding, echoed across the hangar as he explained to younger pilots. Don't chase them sideways, take them up. Make the sky your turn circle. When they stall, that's when you strike. He demonstrated the maneuver himself. At 24,000 feet, he rolled into a climbing spiral, keeping the throttle wide open. In the old Thunderbolt, the aircraft would have shuddered, lost speed, and hung helplessly. With the new blades, it bit the air and kept rising, heavy but unstoppable. German pilots, seeing a Thunderbolt climbing with them, often followed by instinct. That was their fatal mistake. As Gabreski spiraled upward through 2 full turns, the Luftwaffe fighters began to lose lift. Their engines screamed, their wings trembled, and then stall. In that heartbeat of vulnerability, the P-47 reversed. The nose dropped, the propeller bit hard, and 8 machine guns unleashed a storm. In seconds, the hunter became the hunted. Gabreski would perfect this deadly ballet over the coming months, eventually claiming 28 aerial victories, every one in a P-47. Years later, he would tell a historian, "It wasn't a new plane, it was the same plane finally allowed to do what it was built for." Big Week. The test of this new doctrine came in late February 1944, the operation later codenamed Big Week. The Allied command launched the most massive coordinated air assault in history, more than 3,800 bomber sorties and 3,600 fighter escorts in 6 days. The targets were German aircraft factories, the heart of the Luftwaffe's industrial machine. From their bases in England, the Thunderbolts took off in waves, engines leaving trails of smoke that stretched across the sunrise. Over Germany, the Luftwaffe rose to meet them with everything it had left. The sky turned into a cage of flame. Thunderbolts dived through bomber streams, chasing 109s that streaked for the clouds. The new propellers howled like saws, clawing at the thin atmosphere as American fighters climbed in pursuit. On the 3rd day, near Leipzig, Gabreski's squadron intercepted a formation of JG-26, the famed Abbeville boys. 7 Focke-Wulfs fell in 10 minutes. Major Klaus Mietusch, their commander, filed a shaken report afterward. The enemy Thunderbolt can now follow in climb. Previous disengagement method no longer valid. Across Germany, similar reports echoed from every sector. The Luftwaffe's oldest tactic, the escape climb, was dead. By the end of Big Week, the Luftwaffe had lost 350 fighters destroyed and over 100 severely damaged. American losses, 28. The exchange ratio had shifted decisively. What had once been a contest of skill had become a demonstration of industrial superiority, the ability to innovate faster than the enemy could react. Confusion and collapse. Inside Luftwaffe command rooms, panic began to creep through the reports. Intelligence officers studied gun camera footage showing Thunderbolts climbing beside their own fighters. Some claimed it was a new American type. Others argued that the Americans were using lighter fuel loads or hidden rocket boosters. At the Retzland Test Center, engineers examined the wreckage of a downed P-47D-23 captured in February. The broad, paddle-shaped blades stunned them. The official report concluded, incorrectly, that the modification was for better takeoff under heavy loads. No one realized it was the key to air combat itself.
This misunderstanding would cost Germany valuable weeks, time they no longer had. By March 1944, 6 of the 8 Thunderbolt groups in England had completed the transition. Each new squadron that entered combat reported the same thing. The Germans could no longer climb away. The human element. Yet victory in the air was never purely mechanical. It depended on men and their will to adapt. Pilots who had spent months fighting with the old propellers had to unlearn old instincts. The new Thunderbolt was a different beast. It climbed harder, but torque was heavier. At low altitude, a careless throttle could still flip the aircraft. Training was merciless. Zemke drilled his men until muscle memory replaced fear. Captain Robert Johnson described it best. You didn't fly the new Jug, you wrestled it, and if you did it right, it rewarded you by making the sky yours. The Luftwaffe, however, was struggling with the opposite. Its pilots were running out of hours, out of aircraft, out of hope. Doctrines that had worked since 1940 suddenly failed. New recruits were thrown into combat after just 80 flying hours against American veterans with over 300. The technological and human spirals now pointed in the same direction, down. A new kind of fear. For the bomber crews who once watched helplessly as German fighters vanished upward, the change felt almost miraculous. From their plexiglass turrets, they saw Thunderbolts not merely defending, but chasing, climbing into dogfights, and returning victorious. One waist gunner from the 91st Bomb Group wrote home, "Before, we prayed they'd keep up. Now, we just watch them go." Over the Ruhr, over Brunswick, over Berlin, wherever the Luftwaffe appeared, the Thunderbolts met them head-on. March 6th, the battle over Berlin. That fateful day came again, March 6, 1944, the largest air battle ever fought over Europe. American bombers thundered toward Berlin, escorted by nearly 50 Thunderbolts from Zemke's group. German radar picked them up at dawn. From airfields across northern Germany, more than 80 fighters scrambled. At 24,000 feet, they clashed. German formations dove through the bomber stream, firing, then pulled into the escape climb that had once guaranteed safety. But this time, the silver shapes of Thunderbolts followed them upward, their wide blades beating the air like propellers of warships cutting through water. High above the Reich, the Luftwaffe discovered that gravity itself no longer protected them. In minutes, the sky was filled with black smoke trails. 11 German fighters fell that morning. Not a single Thunderbolt was lost. Not a single bomber in their care was shot down. The era of German dominance in the climb, the Luftwaffe's proudest tactical edge, ended that day over Berlin. Echoes of triumph. After the mission, debriefings at Boxstead were almost surreal. Pilots could hardly believe what they'd achieved. Zemke listened quietly as his men described chasing Focke-Wulfs in vertical spirals and overtaking them near Stahl. He simply nodded, eyes cold and steady. The math was right, he said at last. Now they know. Across Germany, Luftwaffe morale began to fracture. Major Gunther Rau, already one of their highest-scoring aces, later admitted that by spring 1944, Thunderbolts were climbing with us. That was when I knew the war was lost in the air. Industrial momentum. Behind the victories, American factories continued to roar. Hamilton Standard and Curtiss Wright produced propellers by the thousands. Republic Aviation modified assembly lines in record time. Crates crossed the Atlantic in endless convoys. Every day, somewhere in England, another P-47 rolled out of a hangar with a new heart. It was not the brilliance of one invention, but the coordination of an empire of production, a nation that could adapt faster than the enemy could react. The shift of the war. By the end of March 1944, spring 1944, Europe was burning, but the tide was turning. Across the English countryside, airfields bloomed like steel cities.
Runways carved through meadows, hangars rising beside hedgerows, barracks humming with nervous energy. The invasion of Europe was coming, and the air would decide its fate. By April, 6 of the 8 American Thunderbolt groups in England were fully equipped with the wide paddle blade propellers. The last 2 were converting day and night, their old narrow blades stacked like relics of a bygone era. Mechanics worked by lantern light, hands slick with oil, while pilots studied maps of northern France pinned to briefing room walls. The Luftwaffe was weakening, but still dangerous. The German fighter arm, though bloodied, remained capable of striking with ferocity whenever it chose. To land an army on the beaches of France, the Allies first had to win the sky. Completely, ruthlessly, irreversibly. The P-47 Thunderbolt would be the hammer. The road to D-Day. The Allied plan for the invasion depended on air supremacy so total that German aircraft would not even dare appear over the beaches. For that to happen, every airfield, radar site, and rail line in northern France had to be crippled. In late April, the 56th Fighter Group and its sister squadrons began fighter sweeps across the Channel. They no longer waited for German raids. They brought the war to the Luftwaffe's doorstep. Thunderbolts roared low over occupied territory, strafing trains, convoys, and airbases. German radar operators listened helplessly as American fighters struck targets deep behind the lines and then climbed away before interceptors could respond. The new propeller made these raids brutally efficient. The Thunderbolt's improved thrust let it accelerate faster out of a dive, climb back to safety before flak batteries could zero in, and carry heavier bomb loads without losing performance. Each mission was a rehearsal for the invasion, a war of attrition fought one sortie at a time. The death of doctrine. By May 1944, the Luftwaffe was unraveling. For years, its pilots had lived by a single truth: the climb meant survival. But now that truth was killing them. Reports from frontline units read like confessions of disbelief. Enemy Thunderbolts are able to follow in vertical climb. Escape no longer possible through altitude. Jagdgeschwader 26, Operations Log, May 14, 1944. Old habits proved fail. Pilots who had survived countless missions suddenly found themselves overtaken by American fighters that should have stalled hundreds of meters below. Those who tried to roll out of a climb were caught by diving Thunderbolts executing new energy-based tactics that left no escape. Major Klaus Mitusch, one of Germany's most experienced aces, described the experience in his diary shortly before his death. They come from below and behind, and they do not stop climbing. They follow us into our own sky. Forged in industry. Behind the front lines, America's industrial juggernaut continued to feed the transformation. Between June 1943 and May 1944, Curtiss-Wright and Hamilton Standard had produced over 10,000 paddle blade assemblies. Every one of them had crossed the Atlantic under the constant threat of U-boats. In workshops from Liverpool to Norwich, crews fitted them to aircraft at a rate of more than 1,000 per month. Each blade, 4 meters long, sculpted from heat-treated aluminum, was a masterpiece of manufacturing. Precision balanced, mirrored to reflect sunlight and deflect tracer fire, it represented more than engineering. It was an idea made physical, that the smallest mechanical change could alter the outcome of a global war. The climb of the wolf pack. At Boxted, Essex, the wolf pack trained relentlessly. Zemke's doctrine of the vertical fight became gospel. Pilots learned to merge with German formations not from behind, but from below, to trade altitude for energy and then reclaim it through climb. Every mission refined the choreography. 2 aircraft in tandem, one engaging, the second waiting below. When the German fighter tried to climb, the lead Thunderbolt followed just long enough to drain the enemy's energy. As the German stalled, the second P-47 struck from beneath. The tactic, soon nicknamed the vertical scissors, turned the Luftwaffe's greatest strength into its gravestone. By mid-May, German commanders were begging for new tactics. But the Luftwaffe's training pipeline was collapsing under fuel shortages. Young pilots went into combat with barely 80 hours in the cockpit, against Americans with 4 times that. The result was slaughter. The sky over France. Late May 1944, the air above northern France belonged to the Americans. Every dawn, hundreds of Thunderbolts rose from English runways, the sound of their engines rolling across the countryside like approaching thunder. From Churchbourg to the Seine, nothing moved in daylight without being seen. At 20,000 feet, the propeller blades carved the thin air, their rhythmic whoomp, whoomp, whoomp echoing through the clouds. Below them, trains burned, bridges crumbled, and airfields vanished under cascades of bombs and rockets. German ground troops gave the Thunderbolt a new name, Der Erdrutscher, the Ground Crusher. June 6, 1944. D-Day. At dawn, the Allied invasion fleet stretched across the Channel. 5,000 ships, thousands of landing craft, a moving continent of steel and courage. Above them, the sky was alive with aircraft, Spitfires, Mustangs, Typhoons, and hundreds of Thunderbolts. From first light until dusk, P-47's prowled the airspace over Normandy. Whenever German fighters dared to rise, they were intercepted and destroyed before reaching the beaches. The Luftwaffe managed fewer than 100 sorties that day. The Allies flew nearly 9,000. Not one German bomber reached the invasion beaches. Not one formation of Thunderbolts was broken. The air belonged entirely to the Allies, an achievement unthinkable a year earlier when Thunderbolts had struggled merely to keep pace. At 28,000 feet, Captain Robert Johnson circled his squadron above the smoke-filled shoreline. Through his canopy, he saw the beaches below swarming with landing craft and men. Later he wrote, "For the first time, I understood what air superiority really meant. We owned the sky, and because of that, they could own the ground." The numbers of victory. The statistics told their own story. In the first quarter of 1944, before the new propellers became standard, American fighters in Europe held a kill ratio of 1.8 to 1. By the second quarter, as paddle blades spread across the fleet, that number leapt to 3.2 to 1. By the third quarter, it reached 4.6 to 1. These were not abstract numbers. They were the measure of survival, of bomber crews returning home, of airfields staying operational, of the invasion succeeding. The paddle blade propeller had not made the Thunderbolt invincible, but it had made it unstoppable. Voices from the ground. For the infantry landing in Normandy, the Thunderbolt became a symbol of salvation. As German artillery opened fire on the beaches, flights of P-47s dropped from the clouds, unleashing rockets and machine gun bursts that shattered bunkers and convoys. Soldiers later said they could recognize the aircraft by sound alone, a deep, confident rumble that meant help was coming. A British paratrooper from the 6th Airborne recalled, "They'd swoop in like angels with guns. You didn't see the enemy planes anymore, only ours." The shadow over Germany. While Allied troops advanced across France, the Luftwaffe crumbled. Pilots who once laughed at the heavy American fighters now found themselves outclimbed, outgunned, outnumbered. Each loss meant more than a downed aircraft. It meant the slow suffocation of Germany's last advantage. By July, the Luftwaffe's fighter strength in the West had fallen below half of what it was in January. Entire squadrons ceased to exist.
Their replacements, young, barely trained boys, took to the air only to vanish in smoke minutes later. Germany's skies had become a graveyard. Industry meets destiny. In the offices of Hamilton Standard in Connecticut, a notice was pinned to the wall in June 1944. Every propeller you finish today is one less American pilot lost tomorrow. It was more than rhetoric. Between design concept and Normandy, only 9 months had passed, a feat of industrial coordination unmatched in history. The Thunderbolt's rebirth embodied a truth about the war itself, that victory was not the work of miracles, but of thousands of small, precise solutions applied relentlessly until
Summer 1944. The storm that had begun over Normandy was rolling east. The Allied armies were breaking through France, crushing what remained of German resistance, and the sky above them was filled with silver wings. The Luftwaffe, once the pride of Hitler's empire, was now a shadow. Bleeding aircraft, bleeding pilots, bleeding time. For every German fighter that rose into the air, 3 American Thunderbolts raided. The air no longer belonged to the hunter, it belonged to the hammer. And the hammer had found a new purpose. The P-47 Thunderbolt, reborn by its paddle blade propeller, was no longer just a fighter. It was now an arsenal in the sky, a weapon of destruction, precision, and endurance. The new role. By July 1944, the great air duels that had once defined the war were fading. The Luftwaffe was retreating behind the Rhine, conserving what fuel and pilots it still possessed. But the Thunderbolts kept flying, and their mission evolved. General Carl Spaatz and General Jimmy Doolittle redefined the Thunderbolt's role. It would now strike the enemy where he could not defend, on the ground. Each aircraft carried up to 2,500 pounds of bombs, rockets, and machine gun ammunition. With their rugged frames and vast engines, the P-47s could dive into combat, unleash their payloads, and climb back into safety before flak could find them. Pilots called it the jug dive. German soldiers called it death from the clouds. Power through propulsion. The paddle blade propeller had done more than fix the Thunderbolt's climb. It had changed how it fought entirely. At low speeds, when a fighter was heavy with bombs, the wide blades grabbed more air, delivering lift even when the aircraft was nearly stalling. That meant shorter takeoffs, tighter recovery from attack dives, and a faster return to altitude. The engine no longer screamed helplessly against drag. It drove the propeller like a hammer striking air. Every rotation meant thrust. Every thrust meant survival. With this, the Thunderbolt could carry more weight than any single-engine fighter in history. It became the workhorse of Allied air power, a flying battleship that could duel with a Messerschmitt in the morning and annihilate a German convoy by noon. The fields of fire. From June through September 1944, the sky over France was a furnace. Thunderbolts flew low, sometimes barely 100 feet above the ground, hunting locomotives, supply trucks, and tanks. The roar of the R-2800 engine became the last sound many German soldiers ever heard. At 400 miles per hour, the fighter streaked across open fields, releasing rockets that turned armored columns into firestorms. Gun cameras captured scenes that looked like the end of the world. Black smoke columns rising from rail yards, fuel depots erupting in orange flame, the twisted skeletons of panzer divisions left smoldering by the roadside. Each mission blurred the line between air and ground war. The Thunderbolt's role was no longer to chase, it was to erase. Between April and September 1944, Thunderbolts flew 88,000 ground attack sorties, losing fewer than 820 aircraft to all causes, a loss rate of under 1%. Statistically, it was one of the most survivable aircraft of the war and one of the most lethal. The pilot's machine. No aircraft inspired loyalty like the Thunderbolt. It was heavy, stubborn, and unrefined, but it brought its pilots home. The 56th Fighter Group, still led by Colonel Hubert Zemke, refused every offer to transition to the new P-50 Mustang. They called their Thunderbolts old friends. Major Francis Gabby Gabreski, the group's ace of aces, often told new pilots, "This plane may not be pretty, but when it's time to fight or die, you'll want her under you." He was right. When German flak tore through wings, the Thunderbolt kept flying. When a fuel line ruptured, the R-2800 kept running. Pilots returned to base with wings shredded, oil pouring from cowls, holes big enough to crawl through, and still landed safely. Its propeller, massive and brutal, could even absorb damage and keep turning. Mechanics joked that the paddle blade could chop down a tree and still bring the pilot home. A weapon of momentum. As Allied armies advanced through France, the Thunderbolt followed like a loyal shadow. Airfields sprang up overnight on captured farmland. Strips of steel matting laid across wheat fields still warm from battle. Within hours of being built, Thunderbolts were taking off again, supporting infantry only miles away. Their missions became rhythm itself: climb, strike, dive, climb again. Each assault built upon the last, each target destroyed, weakening the German front a little more. German commanders reported a nightmare they could not counter. Whenever their columns moved by day, the sky darkened with attack planes. Whenever they tried to retreat at night, reconnaissance aircraft tracked their headlights. The Thunderbolt had become an relentless presence, the sound of inevitability. Inside the cockpit. Every mission began the same way. The pilot strapped in, checked fuel, set propeller pitch, and advanced the throttle. The wide blades turned slowly at first, a heavy rhythmic pulse. Then faster, until the air itself vibrated. At full power, the R-2800 engine generated more than 2,000 horsepower. Combined with the paddle blade propeller, it felt like being launched from a catapult. The cockpit trembled with force, the canopy rattled, the engine note deepened into a chest-shaking growl. Then, suddenly, the aircraft lifted, heavy but unstoppable, rising into the dawn light over the channel. For many pilots, it was the most powerful feeling they had ever known. The ground war from above. August 1944, the Falaise Pocket. Allied armies surrounded tens of thousands of German troops trapped in Normandy. Every road, bridge, and field became a killing ground. Thunderbolts circled overhead like vultures of steel. Whenever the retreating Germans tried to move, the Americans struck. Rockets shrieking downward, machine guns cutting through armor. From the ground, the spectacle was apocalyptic. Entire columns of vehicles burned for miles. Survivors abandoned their trucks and ran for the woods. By the time the pocket closed, what remained of Germany's Western Army was gone. The Luftwaffe, once feared, was nowhere to be seen. The Thunderbolts ruled the air unchallenged. The cost of power. But even victory carried its price. Flying at low altitude was deadly work. Flak guns hidden in trees and barns waited for the descending roar of engines. One hit could rip open a wing or send oil cascading across the canopy. Pilots learned to respect the ground, to fear the unseen flash of an 88mm shell. The propeller that gave them strength also demanded precision. Too steep a dive, and torque could roll the plane uncontrollably. Too shallow, and the rockets would miss. Every mission balanced on the edge of mathematics and courage. By September 1944, the 9th Air Force listed hundreds of Thunderbolts damaged beyond repair. Not by enemy fighters, but by the Earth itself. Still, they flew. Testimony of the enemy. Years later, captured German pilots would speak with a mix of awe and resignation. Major Gunther Rahl, the Luftwaffe ace with over 275 victories, said in his post-war interview, The Thunderbolt was underestimated. We laughed at it once. Then it started climbing with us. Then it started killing our tanks. It became one of the most dangerous machines we faced. Others described how the once slow P-47 had turned into an omnipresent threat, a machine that could not outclimb, outdive, or outrun. In the summer skies of 1944, the Luftwaffe learned that quantity, when combined with quality, was a weapon in itself. The philosophy of innovation. Behind the roar of engines and the thunder of guns lay a deeper story, one of philosophy and design. Germany sought perfection. Every change demanded endless testing, refinement, theoretical optimization. America sought results. When engineers found a solution that worked, they built it at scale. The paddle blade propeller was not perfect. It was heavy, created drag at high speed, and required reinforced hubs. But it solved the immediate problem in months, not years. It was the embodiment of American pragmatism, the belief that good enough today was better than perfect tomorrow. That won wars. Legacy of the Wolfpack. By autumn, the 56th Fighter Group had achieved a record unmatched in Europe. More than 1,000 enemy aircraft destroyed in the air, hundreds more on the ground. They had never transitioned to Mustangs, never abandoned the aircraft that had carried them through the worst years of the air war. Colonel Zimke himself wrote in his final 1944 report, "The Thunderbolt in it."
Winter, 1944. Europe lay in ruins beneath gray skies streaked with contrails. From the Ardennes to the Rhine, the sound of engines echoed endlessly, a sound the Germans had come to fear, the deep, unrelenting thunder of the P-47 Thunderbolt. It was December, and Hitler had made one final gamble: the Ardennes offensive, the Battle of the Bulge. For a brief moment, the weather turned against the Allies. Snow and fog grounded their aircraft, and the German army surged forward, armored columns pushing through frozen forests, desperate for a last chance to split the front. For 5 days, the skies remained silent. Then, on December 23rd, the clouds broke. The return of the thunder. At dawn, the sun rose over white fields stained with smoke, and then a sound like distant drums rolling over the horizon. Hundreds of Thunderbolts took off from hastily built airstrips in France and Belgium. The wide paddle blades bit into the cold air, hurling the heavy fighters skyward like stones from a catapult. They came in waves, 12 at a time, then 24, then 50. Until the very sky seemed to shimmer with silver wings. Below, the German offensive faltered under the sudden roar of Allied air power. Thunderbolts struck columns of armor along the roads from St. Vith to Bastogne, rockets streaking down into tanks clustered for warmth. German officers watching from the ground described the sight with horror. The sky, one wrote, had turned into a machine. The day the Luftwaffe died. Luftwaffe squadrons scrambled to defend the offensive, but what few fighters they had left were outnumbered and outclimbed. The battle that unfolded in late December was the last gasp of German air power. On December 27th, near Bonn, a formation of P-47's from the 56th Fighter Group encountered 30 Messerschmitts attempting to intercept Allied bombers. The engagement lasted only minutes. The Thunderbolts climbed, turned, and dove in relentless spirals. 12 German aircraft were destroyed. Not one American was lost. It was over. By January 1945, the Luftwaffe had ceased to exist as an organized fighting force over Western Europe. The sky belonged entirely to the Allies. From hunter to guardian. Through the final months of the war, the Thunderbolt became a constant guardian over the advancing Allied armies. From the low plains of the Ardennes to the bridges of the Rhine, it struck with mechanical precision. The wide paddle blades, designed for vertical climb, now gave it unmatched acceleration at low altitude. Loaded with bombs, rockets, and machine guns, each aircraft carried the destructive power of a small artillery battery. German armor convoys, once shielded by speed and distance, were now doomed. The moment they appeared on a road, P-47's materialized above them, descending like angels of fire. The arsenal in motion. By March 1945, the U.S. Army Air Forces had perfected an astonishing rhythm of destruction. Squadrons of Thunderbolts operated in rotating cycles. Take off, strike, refuel, rearm, and strike again. In a single 24-hour period, one group could deliver more than 400 tons of bombs and rockets, all from the air. They hit supply depots, bridges, and trains, leaving the German war machine paralyzed. When Allied ground forces crossed the Rhine, the P-47s roared overhead, clearing a path through enemy resistance. Every time a German formation tried to regroup, the Thunderbolts appeared. Every time a new defensive line was drawn, it vanished beneath fire and steel. The wide paddle blade propellers that had once been a desperate innovation were now driving the most powerful single-engine fleet ever assembled. The final missions. April 1945. The war in Europe was ending. The once invincible Luftwaffe had become a rumor. German fighters that still tried to take off were destroyed on their own runways. The Thunderbolts now flew deep into Germany, hunting remnants of an army that no longer had a sky to fight beneath. Over Berlin, the last surviving Luftwaffe pilots rose to defend a dying city. Among them were men who had once mocked the heavy American Thunderbolt. They now faced it in silence, knowing what awaited them. By May 8th, VE Day, the air over Europe was clear. The Thunderbolt had done its work. An American triumph of industry. The victory was not only one of combat, but of production. In just 9 months, the United States had designed, tested, and deployed a new propeller across an entire fleet. 2 companies, Curtiss-Wright and Hamilton Standard, had turned engineering sketches into mass-produced miracles. Republic Aviation modified entire assembly lines in record time. The U.S. Army Air Forces trained mechanics, revised manuals, and shipped thousands of crates across the Atlantic. From concept to combat, the transformation had taken less than a year. Germany, crippled by shortages and bureaucracy, could never have matched that speed. In the words of one American engineer, "We didn't build a better idea, we built it faster." Lessons from the sky. The story of the paddle blade Thunderbolt revealed something deeper than the victory of one machine. It showed that wars are not won by singular genius, but by relentless problem-solving, by thousands of small improvements made in time. The modification itself was simple: more surface area, greater efficiency at low speed, better thrust in climb. But its impact was revolutionary. Before the change, the Thunderbolt was a brute, powerful but clumsy, a defensive escort struggling to hold altitude. Afterward, it became a predator, able to climb, fight, and strike with equal fury. Its transformation mirrored the evolution of America's war effort itself: vast, coordinated, unstoppable once in motion. Voices of those who knew. After the war, pilots who had flown the Thunderbolt spoke of it not as a machine, but as a comrade. Lieutenant Colonel Hubert Zemke, commander of the 56th Fighter Group, wrote, "She was heavy, yes, but she climbed like vengeance once we gave her those new blades. The day she learned to climb, we learned to win." Major Francis Gabreski, America's top ace in the Thunderbolt, said in 1946, "The paddle blade propeller made the jug everything it was meant to be. We stopped chasing, we started hunting." Even their enemies remembered. Major Günther Rahl, one of Germany's surviving aces, admitted, "When the Thunderbolts came with those wide propellers, we lost the vertical. After that, the air belonged to them." Beyond the propeller. The engineering lessons of the Thunderbolt's transformation extended far beyond World War II. The principle that thrust depends on surface area and airflow, not just raw power, became foundational in post-war aviation. From the jet turbine's fan blades to the rotors of helicopters and the propellers of modern drones, the legacy of the paddle blade lived on. The Thunderbolt's design taught engineers that performance is balance between speed and lift, drag and thrust, theory and practicality. It proved that progress is rarely about invention alone. It is about adaptation. The forgotten giant. Yet history has a cruel way of forgetting its giants. When the war ended, the world turned to new marvels: the Mustang, the Spitfire, the Messerschmitt jet. The Thunderbolt, rugged and massive, was quietly retired, its engine silenced in hangars or sold to foreign air forces. Within years, many were melted down for scrap. Their propellers, those mighty blades of victory, stacked in warehouses like forgotten relics. But for those who had seen them in the air, their memory never faded. A single glimpse of a P-47 diving through sunlight, wings flashing, propeller biting, was enough to remember what power looked like. The true measure of innovation. Historians often debate which aircraft won the air war over Europe: the Mustang, the Spitfire, the Lightning. But the truth is more complex. When the war's outcome still hung in the balance, in the winter and spring of 1944, it was the Thunderbolt, reborn with its paddle blade propeller, that turned the tide. Without it, the bombers might never have reached Berlin. Without it, the Luftwaffe might have survived to strike the invasion fleet. Without it, the beaches of Normandy might have been painted in different colors. The propeller's importance was not in its beauty, but in its timing. It came when the Allies needed it most, a perfect solution delivered fast enough to matter. Engineering and destiny. In every great war, there comes a moment when invention meets necessity, when a handful of engineers, hunched over drawings and data, change the